We're going to continue our discussions, and today we're going to talk about time value of money. Time value of money is an extremely important concept in economics and finance, more to do with financial economics or finance. So today's agenda, as you can see, is we're going to define what time value of money is. Then we're going to talk about future value, present value, and we're also going to look at simple interest and compound interest. Some of it is probably familiar to some of you through some of the math classes or courses that you've taken. So what is time value of money? Have you ever wondered why people prefer $1 today than $1 tomorrow? The major reason here is because value of money decreases over time. So the same dollar today cannot purchase as much stuff tomorrow compared to today. So that is the concept of time value of money. The relationship between $1 today and $1 in the future shows you the time value of money. If someone was to say, I will give you $100 today or $100 from 10 years from now, you would obviously prefer them to give that to you today. Not just because you can spend it today, but also because you can buy more stuff today than you could 10 years from now with the same $100. Future value of money is a concept within time value of money. It basically lets you calculate what the value of money would be in the future. So suppose you invested $1,000 on the 1st of January at a rate of return of 5%. A rate of return of 5% implies that every year you would be earning 5%. How much will you have at the end of the year, which is December the 31st? How much will you have by the end of 2 years? So the future value of money can be calculated using this example. On January the 1st, you had $1,000. By the end of the year, $1,000 multiplied by 1.05. 1 represents the original $1,000. 0.05 represents the 5% that you've earned. So now you are at $1,050. And from 2 years from now, then you would take the $1,050 that you have at the end of the first year, and you would do the same multiplication, meaning times 1.05, and you end up with $1,102.50. Notice the difference that the first year you earned $50 as a 5%, and the second year you earned $52.50 as the difference, as the interest. So the difference of $2.50 is what we call compound interest, and I'll come back to that in a couple of minutes. So future value can be written down in this formula. FV equals PV times 1 plus R to the power of T. And you can see FV stands for future value, which is what you're trying to calculate. PV stands for present value, so what the value is today. R stands for the period interest rate expressed as a decimal, and in the example beforehand we had 5%, so you can see 0.05, and T represents the number of periods, so 1 year, 2 years, 3 years, and so on. So future value interest factor, if you were to look at it in a different fashion, would be that component of the formula. So the formula that you have to look at or understand is bolded on the top. Future value equals present value multiplied by 1 plus R to the power of T. So as we were talking about simple interest and compound interest earlier on, a couple of minutes earlier, you can see that the $50 is the interest, which is 5%, but the difference is $2.50. That extra $2.50 comes from the interest earned on the previous year's interest. So in year 1, you had $1,000 to invest. In year 2, at the beginning of year 2, you actually had $1,050 to invest. So that means that you are earning interest on interest. The power of compound interest is very, very extreme. It can be really a good tool for you as an investor, as a saver to understand. And when interest rates or when rates of return are high, meaning 20-30%, it can have a huge impact on your total investments. So when you are reviewing this and you have the PowerPoint in front of you, just go through these questions very quickly. Define the time value of money for yourself. What is the formula for future value, and the difference between simple interest and compound interest. Now, I'm going to present to you a very interesting case. I researched this through a couple of websites. So Manhattan Island was actually owned by Peter Minuit, who bought the island for $24 in 1626. Was this a good deal? Of course it was an amazing deal, right? I mean, if you do the calculations, $24 looks very minute at this point. However, if you were to take the $24 and see what the answer would be in 2008 or 2010 or 2013, which we're currently in, compounded at 8%, it would give you a huge number, probably more than $1 trillion. So you can simply take $24, take 1 plus 0.08, so 1.08 to the power of today's year, which is 2013, minus 1626. It gives you a lot of years, over 300 years, and you'll see the value would be a huge amount of value. The only sad part was he had to sell it back in the year 1627, I think. So I'm not sure the exact year when he had to sell it back. The government probably made him sell it back. Otherwise, that family would be very, very rich. Present value formula is the opposite of future value. So when you know how much you're going to have in the end, and you want to know what the calculation of that, what the valuation of the money would be today, you would now then calculate present value. So you can see by rearranging the future value formula, present value equals future value divided by 1 plus r to the t. And all the components remain the same, except now that you're dividing rather than multiplying. So suppose you need $10,000 in 1 year for a down payment on a house. If you can earn 7%, how much do you need today? So simply 10,000 divided by 1 plus 0.07, which is 1.07 to the power of 1, because we're talking about 1 year. And you would get your answer. It would be less than 10,000, but not too drastically less than 10,000, because you're looking at 1 year. So you want to begin saving for your siblings' university education. Somehow you're being, being very good for your sibling. She or he will need $150,000 in 17 years. You can earn 8% per year. How much do you need today? So you take 150,000 divided by 1.08 and to the power of 17, and you'll get to know the actual amount that you need today. Moving on to the two important relationships for present value and future value. These are critical to understand as they are conclusions of time value of money. The longer the time period, the lower the present value required. So you can see from these two questions, you will note once you get to the answers that the longer the time period, in the second case you had 17 years, you would require less money up front, which is the present value. So the longer the time period, the lower the present value that you require. The second relationship is the higher the interest rate, the smaller the present value required. So as you will learn, or you can look at different interest rates using the formulas, you will notice that the higher the rate of interest, the smaller is the amount that you need today, because you can earn a lot more on that. So those are the two critical relationships from here. And the word interest in this case doesn't necessarily mean interest as you know it. You just put the money into an account and they give you money. Interest can represent rate of return, which means that you have invested your money somewhere and you are earning through different ways, not just interest. But in the language of finance, all of it is called interest, just to represent the fact that these are earnings on investments. And you can have different types of earnings. You can have, rent income. You can have dividends. You can have shares of businesses. You can have all types of different types of earnings, but we call it interest just to represent the fact that these are earnings. Last slide deals with a formula called accumulated value. This is a formula that you may need for your assignment and for your tests. So this represents, as you can see, it's a simple enough formula, but it is a bit longer than the present value and future value formulas. So in this case, this is used to come up with the amount that you may have at the end of your working life. So if you were to retire at the age of 65 and you were to invest money every year for, let's say, 3 years or 5 years or 20 years, how much will you have at that age? So you can see present value here equals money you are investing today or every year on an ongoing basis. R equals rate of return. X is equal 65 minus the first year you start investing, and Y equals the 65 minus the last year you invest. So this is just trying to get you to a final amount of money, how much you will have. If you were to invest, let's say $5,000 every year for 10 years, you will then figure out at the age of 65, when you retire, how much money you will have. If you plan to retire at the age of 60 or 55, you simply change the formula to reflect that. Okay? So hopefully this was an important lesson for you guys. Hopefully you've learned time value of money, and you can use that in your assignments and your real life. Thank you very much.